Finding a regression line. Now remember, we're going to do this by hand for the time being. This says, low mortgage rates and investors shifting assets from stocks to real estate. Real estate's sales and prices keep rising. The following table shows the median or middle cost of sales prices existing single family homes in the United States from 1998 to 2002. This is an old problem. Let X be the number of years after 1998. This is an important piece of information because it tells me what my input variable is. It's X, and it tells me what it represents. And it's not unusual that this happens when you get like 1998, 2002. If the X values are very large, you will tend to put a representation in for that value instead of the actual year. And Y, the median house price for that year. What is the input variable? The input variable is X. And what is the units? Well, it's years after 1998. 1998 represents X equals 0. And what is it? It's the number of years after 1998. The output variable is Y, and the units is going to be in dollars. And what is it? It is the median, that means middle, price of a house. And technically speaking, X years after 1998. You want to get technical about it, that's what it is. Median means middle. Think about we talk about a road has a median. That's a strip that runs down the what? Middle of the road. So when you think about median, think middle. So it would be the price in the middle. So it's not too big, not too small. It's right in the middle of the two. So align the data. I'm going to ask you to do that. And this is my table. In 1998, the price was $128,400. 1999, $133,500. 2000, $139,900. 2001, $147,800. This should be 2002. Too many zeros. $149,900. That's the information they gave me. And when it says align the data, that means this. X is the number of years after 1998. So 1998 is my start year, so it's 0. 1999 is 1 year after. 2000 is 2 years after. 2001 is 3 years after. 2002 is 4 years after. This is my new T-bar chart. That's what I'm going to be dealing with. The reason why we do that is to keep the size of our numbers small. Now with linears, it's not so bad. When you get into the polynomials and the exponentials, you don't have those numbers small enough. You'll end up with these huge numbers when you try to do calculations. Using the table for part B, draw a scatter diagram. Scatter diagram is just a graph of the dots. So at 0, it's about 128.4. At 1, 133.5. Just do a guesstimate. At 2, 139, so it's almost 140. At 3, it is 147.8. And at 4, it's almost 150. Now, this is one of the reasons why you do a scatter diagram. One of the reasons is that when you do a scatter diagram, if I were to take a look at the dots, they all line up except for one. And if you're writing your report, you're going to say to yourself, this is kind of out of place. Either the data is wrong for that year because everybody else lines up into something that looks like it's linear, or something happened that year. So then you do more investigation as to what happened 3 years after 1998 or 2001 that you ended up with that kind of jump. And it might well be whatever happened that year says, I can ignore that year and do a mathematical model just on this. And you're going to say, well, why would you want to do that? Well, if I'm going to pick 2 points to draw a straight line, I could pick the first one and the last one, and I would draw a line. Or I could pick the middle 2. What do you notice? The slopes are different. And then you'd ask the question is, which one would be the right representation for the situation that you're in? So that's another reason why it becomes important that I figure out what happened that year. Because depending upon the 2 points I pick to draw that line, it's going to make a difference in how fast the cost of the house is changing.